Hello, good morning, and good afternoon. Today we're going to be going over right triangle trigonometry. It's some pretty easy stuff, so you shouldn't have an issue. In right triangle trigonometry, we have the saying SOHCAHTOA, which stands for sine, opposite hypotenuse, cosine, adjacent hypotenuse, or tan, opposite adjacent. An example of using this would be, this is a given angle or missing angle. This is opposite to it. This is adjacent to it. And then this is the hypotenuse, which is always across from the 90-degree angle in a right triangle. All right, let's get right into it and start with some practice problems. As you can see, we have a right triangle. It has one side given, and besides the right angle, it has another degree given, and that is 21. We have a missing side here that is marked with X, which means that's the side you want to find. I like to start by writing SOHCAHTOA. When you look at the given degree and the missing side, it lines up with opposite over hypotenuse, which means this is sine. So you need to write sine of 21 equals opposite over hypotenuse. In order to find this missing side, all you need to do is multiply sine of 21 by 12. So sine of 21 by 12 equals x. In order to find this answer, you're going to need your calculator. First, you're going to need to make sure that it is in degree mode, which mine is. If it was in radian, it would be flashing on radian, and all you would need to do was go over to degree and hit enter. So, to find the answer, we put 12 times sine of 21, make sure you close the parentheses, and then you press equal. And then you get about 4.3. So x equals about 4.3. Here's our next problem. And again, I'm going to start off by writing SOHCAHTOA. We have another given angle, a measurement on one side, and a missing side. With our angle, we have a side that is adjacent, and then we have a side that's the hypotenuse. So this is going to be cosine. So you write cosine of 40 equals the adjacent side over the hypotenuse. So 8 times cosine of 40 equals x. So you have 8 times cosine of 40 equals about 6.13. So x equals about 6.13. Here's our next problem. SOHCAHTOA. This will save your life. So we have our missing side, our angle, and then a given side. The missing side is opposite from the angle, while the given side is adjacent. So this is tan. So tan of 35 equals opposite over hypotenuse. So 15 times tan 35 equals x. 15 times tan of 35 equals about 10.5. So x equals about 10.5. Here's our next problem. So this time we have a missing angle, and it's marked with the symbol theta. Remember this. You will see it often. We have two given sides, and they are opposite and hypotenuse to the angle theta. So that would be sine. Sine of theta is equal to opposite over hypotenuse, or 3/5. Now, in order to find an angle, you have to undo the sign. You can't really divide the sign by the 5. So what you need to do is the anti-sign, which would be second and sine, and that would be sine to the -1. And then you'd put 3 divided by 5. And that equals about 36.9. So theta equals 36.9 degrees. In our next one, we again have 2 given sides and an angle of theta. This is opposite and adjacent, so that would be tangent. So tan of theta equals 13/5. So tan or anti-tan of 13/5 equals theta. So second tan 13 divided by 5 equals about 68.96. So theta equals 68.96 degrees. This last problem is a word problem. You'll see these quite often. So it says, Dave stands 75 feet from the base of a tree. From Dave's feet to the top of the tree is an angle of 40 degrees. Using this information, find the height of the tree. I like to rewrite my triangles. You don't have to if you don't want to. So we're trying to find this side right here. It's X or H. They have H. So we have a side that is opposite and adjacent to the angle. So it'd be, what would it be? So it would be tangent. So we have tan of 40 equals X over 75. 75 times tan of 40 equals X. 75 times tan of 40 equals about 62.93. So X equals 62.93. So the height of the tree equals about 62.93 feet. So we have that there. The next thing we're going to talk about is DMS and decimal form. DMS stands for degrees, minutes, and seconds. So degrees is 1/360th of a circle. Now we already know a circle has 360 degrees, so that should make perfect sense. Now into the weird stuff. Minutes are 1/60th of a degree, so you're dividing the degree by 60, and seconds are 1/3600th of a minute, so you're dividing the minutes for seconds. Let's get right into it, and it might make a little more sense. So here we have a problem, and it says write in decimal form, and we have 42 degrees, 30 minutes, and 9 seconds. So what we need to do to get into decimal form is, see here we already have 42. Now that would be a whole number, so it would be 42 plus 30. So if the minutes are 1/60th of the degree, you would write 30 divided by 60, and then we have our seconds here. Seconds are 1/3600th of a minute, so it would be 9 divided by 3,600, so equals 42. 30 divided by 60 is 0.5, and 9 divided by 3,600 equals 0.0025. So all you need to do is add it all together. So that equals 42.5025. And that's how you get 42 degrees, 30 minutes, and 9 seconds into decimal form. Next, we're going to be finding the DMS form from the decimal form. So here we have 29.322. So we're going to write the 29 right off the bat in degrees. So it'd be 29 degrees. The next thing we want to find is the minutes. So let's take this 0.322 and we're going to multiply it by 60 and we're going to find the minutes. So we have 29 degrees and then we have 19.32 and that would be mostly our minutes. Next, what we're going to do is we're going to take this decimal point right here, so 29 degrees, 19 minutes, and we're going to take this 32, well, 0.32, and multiply it by 60 again to find the seconds. So we're left with 29 degrees, 19 minutes, and 19 seconds. So now we're going to talk about the different variations of the original sine, cosine, and tangent. And those are cotangent, secant, and cosecant. As you can see, they're connected. Tangent goes with cotangent, cosine goes with secant, and sine goes with cosecant. Those reasons are because cosecant equals 1 over sine, secant equals 1 over cosine, and cotangent equals 1 over tan.